Yeah, hello guys, you are welcome to my YouTube channel Mathematics Made Easy. So in today's video we'll be solving this beautiful integral, which is integral. Then if we look at the lower limit is also another integral, which is running from 0 to 3 of e raised power of log t squared over 9 dt. And then if you look at the upper limit, we have 1 over d dt of arctan of t. T is from 0 another integral, that's 0 to t r dr. Then into bracket 35 over 8 x squared integral from 0 to pi over 2 sine raised power of 7t dt plus d cube over dx cube of 2x raised power of 4 minus 1 plus summation of n from 0 to 1 of d dx of x raised to the power of 2n. Everything over limit of r tends to negative 3 square root of 2r plus 22 minus 4 over r plus 3 multiplied by x plus x over pi, then multiply by integral from 0 to pi over 2 d theta over 1 plus cot theta dx. Now let's solve this beautiful integral. So solution. Now guys, we want to solve this particular integral, so let's firstly solve for the limits. Okay, so let me start with the lower limit. Okay, the lower limit, which is integral from 0 to 3 of e raised to the power of log t squared over 9 dt. So this is also equal to 1 over 9. It's equal to 1 over 9 integral from 0 to 3. Then we know that e raised to the power of log t squared is the same thing as t squared. So we have t squared dt. So this is equal to 1 over 9. So we take the integral of t squared. So that will be t raised to the power of 3 over 3. Then from 0 to 3. So this is equal to 1 over 9 into bracket 3 raised to the power of 3 over 3. Then minus 0 raised to the power of 3 over 3. So this will be equal to 1 over 9 into bracket, 3 raised to the power 3 will give us 27. And we have 27 over 3 minus 0. So this will be equal to 1 over 9 into bracket 27 over 3 will give us 9. Then 9 divided by 9, so we get 1 as the lower limit. So the lower limit is 1. Okay guys, now let's move to the upper limit. So the upper limit is 1 over d dt of arctan of t. Okay, then t is equal to integral from 0 to 2 of r dr. Now you know that if you differentiate arctan of t, that one is going to give you 1 over t squared plus 1. Then we are now going to have 1 over t squared plus 1. Then the limit is an integral, so that will be at t is equal to, so if we integrate r, we are going to get r squared over 2, then from 0 to 2. Okay, so we are going to have that. Then 1 divided by 1 over t squared plus 1, so that will be t squared plus 1. So we are going to have t squared plus 1. Then t is from what? We have this integral here, which is t is equal to r squared over 2, 0 to 2. So if you apply the limits, I'm talking about this. If you apply the limit, you are going to have 2 squared over 2 minus 0 squared over 2. So probably this is going to give us what? 2 squared as 4. Then 4 divided by 2 is 2. Then 0 divided by 2 is 0. So we have t is equal to 2. That is, at t is equal to 2. Then I'll substitute the value of t here. So we are going to have 2 squared plus 1, which is equal to 5. So the upper limit is 5. All right, so since we already have this upper limit, then the next thing we are going to solve is this integral right here, which is integral from 0 to pi over 2 of sine raised to the power of 7t dt. Now let's solve that integral from 0 to pi over 2 of sine raised to the power of 7 t dt. Okay, now if you make use of beta function, now let's make use of beta function. Then the beta function says if you have integral from 0 to pi over 2 of sine raised to the power of 2n minus 1 t multiplied by cos raised to the power of 2m minus 1 t dt. Okay, so this is going to give you 1 over 2 beta function of n comma m. Okay, now where beta n comma m is the same thing as gamma of n multiplied by gamma of m over gamma of n plus m. And then take note, gamma of n is equal to n minus 1 factorial. Okay, all right, so now since we have all these information, so I can rewrite this integral as integral from 0 to pi over 2 sine raised to the power of 7t then multiplied by cos raised to the power of 0 t dt. So next thing we are going to do is to know the value of n and the value of m. So how are you going to know the value of n and m? Now we know that 2n minus 1 must result to 7 and then 2m minus 1 must result to 0. So that's how we know the value of n and the value of m. Now let's find the value of n. So finding the value of n, 2n minus 1 must be equal to 7. Okay, and then if you collect like terms, so 2n will be equal to 7 plus 1. So we are going to have 2n is equal to 8. Then if you divide both sides by 2, so we have n is equal to 4. So the value of n is 4. Now let's find the value of m. So 2m minus 1 must equal to 0, Then you are going to have 2m is equal to 1. If you add 1 to the both side, then divide both sides by 2, so you have m is equal to 1 over 2. So we have the value of n and we have the value of m. So we can now make use of our formula. Now making use of our formula, so we are going to have this. We are going to have 1 over 2 beta of n is now 4, comma, then m is now 1 over 2. Then you make use of this formula here to know the value of beta 4, comma, 1 over 2. So we can say this is equal to 1 over 2 multiplied by gamma of 4 multiplied by gamma of 1 over 2, then everything over gamma of 4 plus 1 over 2. Okay, so this same thing as 1 over 2 multiplied by gamma of 4 multiplied by gamma of 1 over 2, then everything over gamma of 9 over 2. 4 plus 1 over 2 will give us 9 over 2. Now let's simplify this completely. Now next page. Now simplifying that completely, we have 1 over 2 multiplied by gamma of 4 multiplied by gamma of 1 over 2 over gamma of 9 over 2. That is what we have. Now what is gamma of 4? So gamma of 4 from the previous formula I gave you, so this will be 4 minus 1 factorial, which is 3 factorial, and 3 factorial is equal to 3 times 2 times 1, so which is going to give us 6. So gamma of 4 will give us 6. Then gamma of 1 over 2 is a constant, which is root pi, and moreover gamma of 9 over 2 will give us 105 root pi over 16. Okay, now we have our values, gamma of 4, gamma of 1 over 2, gamma of 9 over 2. So now let's input those values into this. So you are going to have 1 over 2 multiplied by 6. Gamma of 4 is now 6, and then gamma of 1 over 2 is root pi over gamma of 9 over 2 is 105 over 16 root pi. So then if you simplify this, 2 into that's 1, 2 into 6, that is 3. So you have 3 root pi then divided by 105 root pi over 16. So this is going to reciprocate for you to turn the division sign to multiplication sign. So that will be 3 root pi multiplied by 16 over 105 root pi. So you can see that root pi, we cancel root pi. 3 in 3, that is 1. 3 in 105, that is 35. So we have 16 over 35. Okay, so that integral is 16 over 35. Now the next time we are going to solve is this: d cube over dx cube of 2x raised by 4 minus 1. So let me use red ink for that. So we have d cube over the x cube. Okay, so the cube over the x cube into bracket 2x raised by 4 minus 1. It means you are differentiating this 3 times. Okay, so first time if you differentiate this, you are going to have 8x cube. If you differentiate this second time, you are going to have 24x squared. And then if you differentiate for the last time, which is the third time, you are going to have 48x. So we have 48x for that. Now next part will be this. Okay, will be this summation. So which is let me use blue marker for that. So that summation is summation of n from 0 to 1 of d dx of x raised to the power of 2n. So before you can take the summation, the first thing is to differentiate with respect to x. So if you do that, you are going to have summation of n from 0 to 1. Then if you differentiate x raised to the power 2n, so that will be 2n x raised to the power 2n minus 1. Alright, so you are going to have summation of n from 0 to 1 of 2n x raised to the power 2n minus 1. Then you can now take the summation. Okay, so if we take the summation, that will be 2 into bracket 0, then x raised to the power 2 into bracket 0 minus 1, then plus 2 into bracket 1, x raised to the power 2 into bracket 1 minus 1. So this is going to give us what? 2x. So we have 2x for that. So we have 2x for that. Now we are done with the numerator. Okay, we are done with this. We are done with this. We are done with this. Now let's deal with the denominator. So the first one we have is a limit. Okay, limit. So now let's solve that limit. So the limit is we have limit. So let me use another ink for that. So let me use what ink is that? So let me use red ink for that. All right, so now let's solve that limit. The limit, red ink, yeah. Now this is the limit. The limit of r tends to -3, okay, of square root of 2r plus 22 minus 4 over r plus 3. Now if you should substitute r to be -3 here, we are going to get 2 times -3, that one is -6, and -6 plus 22, then that one should give us 16. Root 16 is 4. 4 minus 4 is 0, so you are going to have 0 over, and if we put -3 here, so that will be -3 plus 3 over 0. So we are going to use the L'Hopital rule to solve this limit. Now using the L'Hopital rule in solving this limit, we are going to have we are differentiating the numerator and at the same time differentiating the denominator. Now if you differentiate the numerator, we are going to have 1 over square root of 2r plus 22, and then if you differentiate the denominator, that one is 1. I'm sure you know how to differentiate that. Okay, so now you take the limit r tends to -3. That is, we are going to now put the value of r, which is -3 there. So that will be equal to 1 over 2 into bracket -3 plus 22. Okay, so this will be equal to 1 over -6 plus 22. The square root is there, don't forget. So you put the square root. All right, so this will equal to 1 over square root of 16. And square root of 16 will give us 4. So we have 1 over 4 for that limit. All right, so we are getting there. The next part, or the next term we are doing, is this integral. All right, now let's solve that integral. So you have to be very careful when solving that integral. Okay, so the integral said integral from 0 to pi over 2 of the theta over 1 plus cot theta. Now I'll be using King's rule in solving this integral. So I can set I, let I be equal to this. So if I is equal to that, then I can call this particular equation, I can call it asterisk. Okay, now if I want to use the King's rule, I'm going to have I is equal to integral from 0 to pi over 2 the theta over 1 plus cot pi over 2 minus theta. And we know that cot pi over 2 minus theta will give us tan theta. So this will be equal to integral from 0 to pi over 2 the theta over 1 plus tan theta. Okay, so I can call this asterisk. Now adding this integral and this integral together, so I'm going to have 2i, because I plus I, this I plus this I will give us 2i. Then add this integral and this integral also together. That is integral from 0 to pi over 2 the theta over 1 plus cot theta, then plus integral from 0 to pi over 2 the theta over 1 plus tan theta. Okay, then this can also be written as integral from 0 to pi over 2. You know, you can put that in brackets. That will be 1 plus cot theta, then plus 1 over 1 plus tan theta, then you put your d theta. Now if you should simplify this, if you simplify 1 over 1 plus cot theta plus 1 over 1 plus tan theta, definitely you are going to get what? You are going to get 1. So you can try that in your leisure time, you check. So that one will give you 1. So you are going to have 2i is equal to integral from 0 to pi over 2 1 times d theta. So that is 1 d theta. Then if you integrate that, you are going to have 2i is equal to theta. Then you take your limit from 0 to pi over 2. So then we are going to have 2i equals pi over 2 minus 0. So we're going to have 2i equals pi over 2. Then if you divide both sides by by 2, so you have I is equal to pi over 4. So this integral right here will give us pi over 4. Now let's check what again. We've done this, we've done this, we've done this, we've done this, and we've done this. So now let's bring all those values together. Okay, so let's bring all those values together. All right, bringing all those values together, I'm going to have integral. So the lower limit is 1, the upper limit is 5. Okay, from what we got, then that will be 35 over 8x squared. Then the integral from 0 to pi over 2 of sine raised to the power of 70. So we got 16 over 35. All right, then plus the cube over the x cube of 2x raised to the power 4 minus 1. We got 48x. So plus 48x, and the second one, which is summation of n from 0 to 1 of ddx of x raised to the power 2n, we got 2x for that. Then everything over. Now the base, the denominator for that limit we got 1 over 4. So that will be 1 over 4 multiplied by x, then plus x over pi. For that integral we got pi over 4, then everything dx. All right, so this will be equal to, now you can see 35, we cancel out 35, 8 in 8, that is 1, 8 in 16, that is 2, and then 48x plus 2x, that one will give us 50x. Then we have integral from 1 to 5 of x squared multiplied by 2, so that will give us 2x squared. Then plus 50x, okay, plus 50x, then everything all over, x over 4, pi will cancel pi here, okay, then it will remain x over 4, x over 4, so x over 4 plus x over 4, so that will be 2x over 4, then dx. All right, so 2 in 2, that is 1, 2 in 4, that is 2. So you can write this as 2 multiplied by integral from 1 to 5 of 2x squared plus 50x over x. Then if you apply linearity, so you're going to have 2 multiplied by integral from 1 to 5 of 2x squared over x dx, then plus 2 integral from 1 to 5 of 50x over x dx. So this will give us, 2 multiplied by 2 will give us 4. So you have 4 integral from 1 to 5, and then x is going to cancel one x here. So you have x dx plus 2 multiplied by 50 will give us 100. Then integral from 1 to 5, then x will cancel x. So you have dx. Okay. So now this is going to give us 4. Then if you integrate x, you're going to get x squared over 2 from 1 to 5, then plus 100 into brackets x from 1 to 5. So this is equal to 4 into bracket. Then if you apply your limit, so 5 squared over 2 minus 1 squared over 2, then plus 100 into bracket 5 minus 1. Okay. So this will be equal to 4 into bracket 25 over 2, then minus 1 over 2 plus 100 into bracket 4. So 25 over 2 minus 1 over 2 will give us 24 over 2. So we have 4 into bracket 24 over 2 plus 400, because 100 times 4 will give us 400. So this will be equal to, now 2 in 24, that is 12. So we have 4 into bracket 12 plus 400. And then 4 times 12 will give us 48. So this will be equal to 48 plus 400. And then 48 plus 400 will give us 448. So that's the answer to that beautiful integral. That is the integral from 0 of another integral, the lower limit is another integral. So 0 to 3 of e raised power of log t squared over 9 dt. Then the upper limit, which is 1 over d dt of arctan of t equals to 0, t equals to 0 from 2r dr of 35 over 8x squared integral from 0 to pi over 2 sine raised power of 7t dt plus d cube over dx cube 2x raised power 4 minus 1 plus summation of n from 0 to 1 of d dx of x raised power of 2n over limit of r raised power of minus 3 square root of 2r plus 22 minus 4r plus 3x plus x over pi integral from 0 to pi over 2 d theta over 1 plus 40 theta. Dx is equal to this beautiful result, 448. Okay guys, don't forget to subscribe to my channel, like my videos and share. So see you in our next video. Thank you.